Hello everyone, welcome to the channel Top Gate. In this video, we'll see one more example of minimization of DFA. In the previous video, we have seen the need of minimization of DFA and we have seen the steps that we take to minimize a DFA. In this one, we'll see one more example of minimization of DFA. So here we have this DFA, the transition diagram of a DFA, and this DFA has to be minimized. So here I have just made the transition table for this particular transition diagram. Clear? So the very first step in the minimization of DFA says that we have to eliminate all those states which are not reachable from the initial state, or there is no path to those states from the initial state. So if we see this closely, if we analyze this one, we can see that Q2 and Q4, these both states are not reachable from the initial state. There is no path from the initial state to these two states, and therefore they both have to be eliminated from this particular DFA. So therefore, from this transition table, I will just eliminate this one. I will eliminate Q2 and I will eliminate Q4. So in the minimization of DFA, I will not consider Q2 and Q4. So from my this transition diagram, Q2 and Q4 both are gone. So let's just delete these states so that it will be easier for you to understand. So both of these states are unreachable and therefore we have eliminated both of these states. Now in this DFA I have only 4 states: Q0, Q1, Q3 and Q5. Q3, Q5 both are my final states. Q0 is my initial state. Second step says that we have to make 2 sets. We have to make 2 sets of final and non-final states. That will be called as pi 0. Now pi 0 is the 0 equivalence. So in pi 0 we'll have 2 sets. One set will be the set of non-final states. One set will be a set of final states. So let's just divide this. Here we can see that the final states are Q3 and Q5. So I'll just make Q3 and Q5. That is one set. And next one is I have Q0 and Q1. Both of these states are non-final states. So this I'll call this as set number 1 and this as set number 2. Now set number 1 and set number 2 both have 2 elements, and therefore I have to make table for set number 1 and set number 2, and we'll see that whether this set number 1 or set number 2 can be further divided or not. So now let's start for set number 1. So for set number 1 I'll make a table, and in this table I'll just write state and 0 and 1, and in state I'll write Q3 and Q5. That is for set number 1. Now I'll just see that for Q3 in the main table where it is transiting with input 0. So for Q3 it is going to Q5 and Q5. Now Q5 belongs to set number 1, so I'll write set number 1 here. Similarly there also with 1 it is Q5, so I'll write set number 1 here. Similarly for Q5 it is Q5 and Q5. Q5 belongs to set number 1. Again I'll write set number 1 and set number 1. So now you can see in this one that Q3 and Q5 both are exactly similar. 1 1 they are getting set numbers. So therefore this Q3 and Q5, the set number 1 will not be splitted. It will be as it is. Clear? So we don't have any change in this one. Now I'll go for set number 2. So for set number 2 you can see that again I'll write state 0 and 1. In state I'll write Q0 and Q1. Now for Q0 I have Q1 and Q3. Q1 belongs to set number 2 and Q3 belongs to set number 1. Fine. Similarly for Q1, Q0 and Q3. Q0 belongs to set number 2 and Q3 belongs to set number 1. Clear? So you can see here that set number 2 also has similar kind of elements. Therefore this set 2 will also not be splitted. So this pi 0 will become my final DFA states. So in the final minimized DFA, I will be having only 2 states, that is the combination of Q3 and Q5 and the combination of Q0 and Q1. So now let's quickly make the table for the final minimized DFA. So the final DFA table will be, I have this state and then 0 and 1. One state I have is Q0, Q1. One state I have is Q3, Q5. Okay, and since Q0 was initial, therefore this will be your initial state. And since Q3 and Q5 are final, therefore wherever we are finding Q3 and Q5, every state will become the final state. This Q3, Q5 will become the final state. Now, Q0, Q1, I'll go to the main table. Q0, Q1, I am having Q0, Q1 and Q3. So, I'll write Q0, Q1 and Q3. Now, I'll see whether Q3 is here or not. So, Q3 here is not alone. Q3 is with Q5. So, I'll write Q3, Q5 instead of Q3 alone. Okay. Now, Q3, Q5. Q3 and Q5. I'm having Q5. Q5 is not here. Q5 is here in the combination of Q3. So, therefore, I'll write Q3, Q5 here. Similarly, here also it is Q5. Again, Q5 is not here. It is in combination with Q3. So, I'll again write Q3, Q5 here. That is the final minimized DFA transition table. Now, let's just make the transition diagram for this one. I have only two states. I will draw these two states, Q0, Q1 and Q3, Q5. That is my final state. Now, Q0, Q1. On Q0, Q1, I have a self loop of 0, and with 1, I can go on to Q3, Q5. So, this will be 1. Similarly, Q3, Q5, with 0, it is moving on to self state. With 1, it is moving on to the self state. So, here I have a self loop of 0, 1. So, this is my final minimized DFA. So, in the main DFA that was not minimized, it had 1, 2, 3, 4, and 5, 6. 6 states were there. And now in the minimized DFA, you can see that we have only 2 states. That is all. Thank you so much.